Right. Where you're going to learn in this second and higher order. Second and higher order differential equation. In this, you're going to learn about complementary function. Complementary function, which you're going to write based on the roots. Next, you're going to deal with PI, that is going to be your particular integral, where general solution, your GS is going to be complementary function plus particular integral. When you are going to find that PI, when your RHS side is not equals to 0, when it is in the form of non-homogeneous form, right? They are the cases are there for writing the
Ma'am, could you please repeat that?
when you are going to find that a PI case, when it is in the form of non-homogeneous differential equation, under there you are going to find that particular integral. When it is equals to, suppose you are having your equation that is that will be in the form of f of d into y, which is equals to 0. This is known as homogeneous differential equation. When your f of d into y, which is equals to some function x, this also it's not equals to 0, it's equals to some function, that is known as non-homogeneous differential equation. When it in this form, when it is in this form, you're going to find both. Here you're going to find complementary function. First half will be complementary function, second half will be your particular integral. When it is a homogeneous form, then only you're going to find here complementary function. When it is a homogeneous differential equation, you have to find only CF. When it is non-homogeneous differential equation, you have to find both. First, you are going to equate the given differential equation equals to 0. Then you are going to find that your complementary function. I will give you the cases, how you are going to write the complementary cases. Then after that, you are going to find the PI with depending on this x. This x is having a 5 types of rules are there. According to that, you have to apply your PI for finding that complete solution. The way of writing your PI is
Yes, ma'am.
PI formula. PI is equals to 1 by f of d into your x, or you can take it as a q of x also you can take. Where this q of x is having rule 1, then it's rule 2. Rule 1, how you are going to declare? When it is in the form of e to the power of ax, that is your rule 1. Second rule, it's going to be in the form of sine ax or cos ax. Then next will be your third rule. It is going to be in the form of x to the power of k. Next will be your fourth rule. It is in the form of e power ax into, sorry, it should be not x. It should be just e power x, sorry, e power x into v of x into v of x, where this v of x can be in the form of sine ax or cos ax, or it can be in the form of x to the power of k. I'm talking about this v of x. This v of x can be in the form of x to the power of k, or it can be in the form of sine ax or cos ax. Depending on this v of x, you have to choose the method where this e power ax, when you're going to find
Ma'am, can you just repeat from the beginning? Because
from where.
I lagged out. Ma'am, because I read, like, my screen started to blur after you wrote Q of X.
Okay, okay, fine. See, I'm talking about the fourth rule. The third is clear for you?
Ma'am, I didn't hear anything. Like, I heard the non-homogeneous equation part.
Okay, okay, okay.
Just
Okay,
after that, I
okay,
haven't
okay,
heard.
okay. Cool down. See, you are for finding the pi. That formula is equals to 1 by f of t into q of x. Right? This is the formula for your pi.
Ma'am,
In this,
ma'am, what's Q of X?
q of x. Or you can write as a simple x only. This q of x can be in the form of your rule 1. That rule 1 is saying as in a what? For your finding your pi, this pi is having some rules are there. Your rule 1 will be when it is in the form of e power
Can you
ax.
scroll up? Ma'am,
Your voice I'm not
can you just scroll up for 1 second?
scroll up.
No, ma'am, can you just scroll up? No, ma'am, can I see the top part? Yes, ma'am. Okay, ma'am, 1 by f of d, ma'am. But then where did q of x come from? Like that q
No,
of
no,
x.
no. That is a notation. Either you can write as an x or you can write as an a q of x. This is only notation that is. Or I have
Yeah,
written in there.
ma'am, but then where did that? No, ma'am, yeah, ma'am, but where did that x?
Where?
Ma'am, but where did that x come from? That x or
That
q
is,
of
you
x?
are going to solve
Ma'am,
for the
that x that
non-homogeneous.
which you have written.
Yes, that you are going to solve
Ma'am,
for the
so is it that x
non-homogeneous.
which is
Suppose your question is going to be framed in this way. Find
okay?
the pi.
Ma'am, is it the same x which you have written on the?
Yes, it's the same. It's the same. Just what I'm saying here, you can
No, is
know.
it the RHS? Is it the RHS?
Yes, that this your x is going to be the RHS. For your rules are going to come on you. For these rules will go for
Okay, yes.
non-homogeneous. This will go for non-homogeneous differential equation. The rules will come under non-homogeneous differential equation, where the first rule is your e power ax, second is your sin ax or cos ax, third is going to be x to the power of k, fourth is going to be e power ax into v of x, where your v of x is the function of x. It can be in the form of sin ax or cos ax, where your fifth rule it's going to be, it's simply x into v of x. These five rules are there for your non-homogeneous differential equation. Before proceeding for this one, you have to know about how to write the complementary function.
Can I just see the rules once more? I just need to write it down.
Yeah, okay, fine, no problem. I will erase this one. Otherwise, you will get confused. Yeah, these are the rules.
Is it e raised to? Ma'am, is the rule? Ma'am, what is rule one?
E power x. My screen is not visible to you properly.
No, ma'am, I couldn't see that part because it was up. But now I can see. Yes, ma'am.
Yeah, done. So after this, you're going to see about the complementary function. How you're going to write the complementary function. Note this one, it's very important. It should be on your fingertip. Sorry, it should be f of d is equals to 0. The first one, if the
F of
roots,
what, ma'am? F of
what,
dy is equal to 0. Okay.
yeah, f of d, or otherwise I'll write it properly. F of d into y is equals to 0. So first case, if roots are real and distinct. Distinct means what? If roots are real and distinct. Then how you are going to, distinct means what, Aditya?
If
Distinct
the
means different. It's going
yes,
to be
ma'am.
different values.
Yes, ma'am.
Hmm. Right. Then if you're getting your roots are real and distinct, then you're going to represent your CF. It's denoted by y suffix c, which is equals to c1 e to the power of m1x plus c2 e to the power of m2x plus c3 e to the power of m3x plus so on cn e to the power of n into x. Here your m1, m2, m3, so on till mn are the roots. Mn. So your m1, m2, m3, so on till mn are the roots. If you're getting your roots are real and distinct, in this way you're going to represent. Your second, if roots are real but repeated but repeated r times, then you're going to represent your complementary function y suffix c is equals to e to the power of, or e to the power of m1x into c1 plus c2x plus c3x square plus c4 x cube plus so on, then cr x to the power of r minus 1, and where this one you can write over here also. Instead of writing in starting, it's better to write it end over here. X to e to the power of m1x. If the roots, it's real, but it's repeating r times, then you're going to, suppose if your roots are repeating occur thrice, then you're going to write c1 plus c2x plus c3x square plus c4x cube. Then close it, e to the power of the root, whatever the roots you got, that root you're going to replace. Next occur your third one. If roots are, if roots are complex roots, complex roots which will be in the form of alpha plus or minus I beta, where your alpha is going to be the real, where alpha it's going to be real part, and where beta is going to be imaginary part. Right, in that case, how you are going to represent your complementary function? Y suffix y, sorry, complementary function y suffix c, it's equals to e to the power of alpha x into c1 cos beta x plus c2 sin beta x. This is the way of representing your complementary function when the roots are complex roots. Next will be the fourth one. If your roots, fourth one, if roots are complex roots, complex roots but repeated, but repeated are times, then you're going to represent your complementary function in this way. Y suffix c is equals to e to the power of alpha x into c1 plus c2x plus c3x square plus so on cr x to the power of r minus 1 into cos beta x. Then next it will be beta x plus next will be your d1 plus d2x plus d3x square plus so on dr x to the power of r minus 1 into sin beta x. When your roots are complex roots and repeated r times, you're going to represent in this way. Aditya, is it clear? You're there or you're off?
No, I'm there, ma'am.
Is it clear? If you are thorough with this four types
Yes,
of
ma'am.
roots, then with the combination mixture you can write. If the some roots are real and some roots are complex, then you can represent them as an easily. One I will show an example. If your fifth one, if one root is real and another root is complex, is complex root, then your complementary function cf y suffix c is equals to e to the power of m1x. This is your first root. That root is real. Then after that plus second root is your complex. That will be e to the power of alpha x into, here should be c1. Then next c2 cos beta x, then plus C3 sine beta x. Is it clear? Yes, Aditya, is it clear?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Shall I scroll up, or you have copied?
No, no, ma'am. No, ma'am. No, ma'am. I didn't copy.
You didn't copy it. You need a time for copying. Okay, copy it on.
Ma'am,